Hello, that sound good? Everybody can hear me? Sound great. All right. So this is more of just like exploration of an idea than like a concrete, thing that I'm going to say, hey, and here's the great outcome of this. This is just an idea I've been really into for the last year or two, or I don't know, a while. But I've been really interested in like exploring more of the trailing edge of computation, and we're going to start talking about that with some stories. So this is a digital pregnancy test. It's kind of a funny device, and here's the digital pregnancy test running Doom. Of course, it's not really running Doom. That was just the OLED being driven by another controller. But there is a couple of funny things about this in reality. One is it's just a regular strip test with an optical reader, a microcontroller, and a display. So if you want to pay like 5 to 10 times the price to have a computer read the strip for you, you can get that. But there's another funny thing about it, which is that the 8-bit controller in here, it runs at 4 megahertz with 1 instruction cycle per megahertz, and it makes it about as fast as the 8086 in the original IBM PC. So in a period of 40 years, we went from introducing desktop PCs to the world and costing about $100 to be in a device that you pee on once and throw away, right? And that's my first story. And I have another story here of Doom, right? So Doom came out in 1993. And actually, you know what? This answers that question. It was a 46 because the top-end system was a 46. But the low-end system was a 386SX at 33 megahertz. Okay, and 4 megabytes of RAM was required. And all these price numbers I've put in here, I've inflation adjusted all of these just so we can compare these prices. So it was not $2,000, it was something else, but I did the inflation adjustment. So for $2,000 to $2,500 is how much you'd have to spend on a system to run Doom. In 2006, roughly 10 years later, you could run on a $200 Nintendo DS. And so we went 10 years in the future and we lopped a zero off the end of the price tag. And if you go to today, we can run Doom on an RP2040 based SBC for like $4, right? So we've gone all the way into the future, and we've lopped a couple more zeros off the end. And because we've got there, we can also run Doom on a keycap, right? So, you can just, forget the computer. But so let's go to the last little story I have here, which is this was the Mac 128K released in 1984 in $25. That's about $7,500 today. And now we can run it on a $40 RP 2350 based SBC, right? So we went from $8,000 to $40 over the period of, 40 years in this case, right? So this is just this trend that we're getting, these computers are getting cheaper and cheaper and cheaper, right? We're getting more and more and more cheap compute. So, that's what all of these things have in common, right? Is until the, what is that, 2012 or so, around the 20 nanometer process, every new process node was half the cost per transistor. And so you have this is a log scale, and so we've got a nice linear line on our log scale. We're seeing that the price is just dropping. And so what we were doing with those, right, is we were shoving more and more and more transistors into ICs to get more and more features. But we actually didn't have to do that. We could have said, well, actually, that's enough compute power. Let's just make them half as expensive. And so I think that's a really interesting idea to explore is like, well, what if we looked at the compute that we had in the past and said, well, what could we do with that same amount of compute, but at much more accessible price today? So I think in terms of like, hackers and DIY, these are really the heroes of the story today. Now there are other great processors like Atmel processors and SMT processors, but these ones have a sort of nice niche between cost and performance and ease of integration, and you see them in so many things, right? So these are a bunch of projects that have them. I have one of these here, and I've got a bunch of ESP32 random devices. Like this is a cute little $40 computer with a battery and everything. This is neat. This is $100. This is a ZX Spectrum emulator that uses the PCB as the keyboard with capacitive sensors. It's a cute device. And all the stuff I have here is open hardware, which I think is kind of cool. Because not only are these cheap, they're also really easy to use. And so that's really made a lot of things accessible. But what if we wanted to go really cheap, right? Well, so this, I have some devices I built with these. And in fact, if somebody wants one of these, I can give you one of them after the talk, because they're 10 cents, right? So you can now get a CPU that's 10 cents. And this is also about the same speed as the 8086, right? So we can now run something that's about as powerful as the 8086 with a bunch of peripherals and RAM. So this is 2K of RAM, 16K of flash, SPI, I2C, UART, built-in clock. The only board support you need for these is a coupling capacitor. You know, you don't really need much to run these things, and they're pretty easy to program. But you know, let's take a step back. In the 90s, we did like gaming, publishing, office work, web. And today we do gaming, publishing, office work, web. I would say the only thing we do today that's actually different is this AI stuff. Like that, none of the apps we really run are different than the apps we were running in the 90s, right? We kind of seems to be, we got things. And I don't want to say, we're absolutely doing more interesting things or more with the computers. We have more polygons, we have better sound, we have internationalization and UTF-8, and we've got all sorts of great stuff. It's not that we got nothing for that, but if you look at the kind of problems we're solving, those problems really haven't changed. What if we said that, you know, maybe we could settle for enough? And so this is a project that had that exact idea, right? So this is a UXN, and they've got there's another name for the I/O and interface stuff I've forgotten the name of. But this was somebody who got really frustrated. They were a mobile app developer. It's produced by a group called Thousand Rabbits. It's a couple. And they had a number of frustrations. They were living on a boat and power was scarce, and they realized how much power their computers used. And then also they'd been like iOS developers. And they were really frustrated that, you know, if you were an iOS developer, something you learn is that if you don't keep updating your app, eventually it disappears because Apple loves to make breaking changes in their APIs. And so apps just bit rot out of existence. And they were running, I think, like a Commodore 64 or Nintendo emulator, and they're like, wait, I can't run the software I wrote 3 years ago. That doesn't run anymore, but I can run this software from the 80s. Like, there's something interesting there. And they read a lot of other stuff, and I think one of the things that input into this was interesting. They were reading about Smalltalk, and something they read said, well, Smalltalk is a 1-year language. It takes about 1 engineering year to write a Smalltalk implementation. And they were like, well, what if we had like a 1 month something or a 1 week something? What would that look like? And so they said, well, they had this idea of perma-computing. So they said, well, what if I wrote a virtual machine? It's not a virtual machine for any real instruction set. But they basically said, I want to take the programming model of things like the Commodore 64, the 6502 kind of family of computers, and that's speaker. So I want to take that, and they want to make a platform that's really easy to port to things, and so software that you write on this will never become obsolete. You'll always be able to write a UXN emulator for this thing. And so I thought that was an interesting idea. And I think that kind of pulls sort of together in the end of for what I wanted to say is that, you know, we live in an era where computation costs almost nothing, right? We can get desktop PC class controller, CPUs, microcontroller CPUs for 10 cents. We can get an ESP32 is about as fast as like a 386 or 486. That's like a couple of bucks, like $4, right? $2 to $4. We can get these things. So computation is now cheap. What can we do with that? And we have an option now to build sustainable compute that we control. This is now in reach. And I think where UXN is in some ways as much of an art piece as it is something like that, I think the ideas there are interesting. What if we built a new operating runtime built with the best of 90s technology, with state-of-the-art 90s technologies? We could build interesting experiences and interesting applications that we could run on hardware that we can all afford to build and maintain and play with ourselves. And I think that's a really interesting idea that I think is worth engaging with. That's what I wanted to say. Questions? Comments? Well, you're telling me somebody got it running on a vape recently, so.
To run Doom on a disposable vape, that's...
Martin reverse engineered you used JTabulator to reverse engineer the unnamed Atmel type chip that was, or Cortex chip that was running the vape, and he's got one that's a bitmap display, and you can just run whatever you want.
Oh, excellent. I do have, if people want to play with anything, I have some of these items. I think they're pretty fun. Yeah.
So are people writing basically in the assembly language of this virtual bytecode, or is it
Yeah, actually, so that one of the things, so these are all apps written for UXN. For aesthetic reasons, or I don't know. The people that build that, you only can program it in assembly. They don't have any programming languages, but they have a built-in editor, so it's got a self-hosted development environment. So these are all apps written in UXN assembly, probably written in UXN on self-hosted itself.
But I guess if you wrote a compiler in UXN, then you would need it forever.
Yeah, I mean, I kind of think it would be interesting to build something on top of WebAssembly, just because it's a really well thought out runtime, and there are, like, for 8-bit micros, for fast things, whether you want, just a simple interpreter or whether you want a fancy JIT, you can get those things. So I kind of think that's an interesting target, but yeah.
Well, your browser at the OS seems to be the way to go for a lot of things.
Yeah, and there certainly is UXN stuff that will run in browser if you want to do that. My personal interests are more in like, hey, how can we actually put this in hardware so we can actually have devices we own? I think is this going to, do I imagine that people would actually want to use these who aren't people that want to do that? Absolutely not, right? But I think there is a community of us out there that would like to answer the question like, hey, how much of our compute can we pull back and actually be in control of? And how much of I'm never going to have my own fab, but how far can I get to things I actually have control of? And not because I think I don't know. I'm not taking a Richard Stallman stance on this. I think it's an interesting question to answer and an experiment to run more than an ideological belief,
What were you doing with that, the tiny little chip? Is it CH32?
Yeah, so I've been using a couple of them. This one is, whoop, let me drop it. This one. Yeah, this one I'm trying to build a virtual pet with a $1 BOM cost. So I've got a button, an LED, a speaker, which I've never gotten around to making work. But I want to make a virtual pet that I can give away. So this is just development hardware for that project. I'm on and off again on it. Right now I've just spent a lot of time trying to do software debounce for double clicking, and that's just a bad idea with a really clicky thing. I've decided that was the wrong path. I spent probably a month trying to make that work well. It just never did. It's too bouncy. And I added a capacitor, and now it works much better.
You can use a TTP223 capacitive touch.
There are a few cents. Well, but the switch is part of the experience. This is a really clicky switch. This is one of the more expensive components on this. I think it's more expensive than the microcontroller.
Yeah, well, that's probably why. If you bought one of the super cheap, nasty ones, they probably work better.
It's true. Well, I could just get one of the diaphragms that you tape down over it. That would probably cost me a penny.
So, when you got the 3203, did you get a buy from LCSC or something?
No, I think I got just them on AliExpress. If you want some, here, I think I have I don't know how many I have here. I don't know. I have 100 or something like that around. These ones, I've got a few different ones.
They're more expensive though.
Do you want to take? You can take a couple if you want. Just cut a couple off the scissor.
Thanks.
I mean, I don't want to give them all away. I still want some more of those, but
I'll just take a couple.
Yeah.
Just play with it.
no, I think that they're a fun chip. I would recommend the CH32003 Fun development environment for them. So the manufacturer's development environment is Moon River, and it's weird and stuff. There's an open source one built on GCC. You can take a couple of, whoever wants some, take one or two.
I have a bunch of the QFN 20s.
Okay.
If you want any of those. I don't have any of this one though.
Yeah, I actually, if you really want, I also have some 8-pin ones too. If somebody wants some of those too.
These are the 8 pins.
Oh, those are the 8 pins. I've got the 20 pins as well.
Yeah, yeah.
Oh, the 8 pins are great.
No, you got this I own, but it's like a 80-20.
Except cheaper.
I've also got some of the 006s, which are interesting. They like doubled the RAM and flash on them, but it's not. It's multiple instruction cycles for a lot of things. So it's actually slower at the same clock rate. But if you care less about speed and more about RAM and flash, that's the way to go.
Like the idea of micro interactive archives of personal data that are kind of heirlooms. So
Yeah.
just like a wiki on a stick that you could, basically more or less just need a Bluetooth or RFID, or like I want something that I can hold up the camera to my phone to, and the LED is flashing fast enough that that is my data signal.
Yeah.
So my entire data interaction with my micro wiki on a stick is just an LED or two that I'm pointing my camera at, and that's what's doing the data transfer with it.
Yeah, actually, my spouse used to have a wearable electronics company that you would program. It was like a little Atmel or PIC or something like that. But you could do the opposite. You could hold it up to the screen and had an optical sensor. Yeah, that would program it. Yeah.
Yeah, that's
So my meter's got a USB, like a full USB connection on here.
Well, it's just all getting so cheap. So I haven't played with them yet, so I can't tell you how well they work. But this is like a 10 or 30 cent another microcontroller with Bluetooth LE in it at that price point.
Yeah.
So I haven't used that one yet, but
70. Oh yeah, yeah.
I just think it's like, I mean, it's the point now, like, why did they put a microcontroller in that pregnancy test? Well, they could have used discrete logic, but that would have probably been more expensive because, if you have some like discrete logic that does some function, but you're going to sell a lot less of those than you're going to sell of the microcontrollers. You're going to get better volume on the microcontroller and better scale.
And the same with the vape. Why would you use, like, it used to be that if you were making like an alarm clock, you'd get a custom LCD display for an alarm clock.
yeah.
Nowadays, it's just a lot cheaper to just get a plain old generic OLED display in whatever size it is, and you buy a million of them, so you get them for $1 a pop, and then you just drive with a micro, and you've got your 50-cent micro, the whole thing costs way less than a handful of discretes. And even like old school, 17-inch displays are just too expensive to produce now. It's just easier to have a generic display and just run it the micro. So it's a bit sad. Because every time somebody throws away one of those vapes, that's a whole bunch of processes.
My first three computers put together in the trash.
Yeah.
So weird.
So somebody here brought in a whole bunch of them. So if you want to pull apart a bunch of vapes, we have dozens and dozens of them.
The part that's getting derailed with one of the things that I really want infinite supply of are, if you went to a national park 15 years ago, they had keychains, any tourist trap had keychains that just had an LCD on it on one side and a solar panel on the other, tiny little battery in there, and it would just flash the entire screen, clear or dark, and underneath it would be your name. So you then just had a keychain that just flashed black, and then it revealed your name underneath it. And so, dead simple. I really want that because I want to put a retro-reflective tape or coating behind that. And then you can have things out in the world that you hit with a flashlight, and that thing is flashing at you.
Yeah.
But you're actually the one that's supplying the energy to it. You're walking in the woods, and it's not just a light, solid on beacon that's like, but now you can put a few of those buttons on your back, and it's not just reflecting the light back, it's blinking the light at you because it's turning it on and off.
Well, there was like back in the 90s when smart dust was the thing. That was one of the ideas for communication, where you'd have a retroreflector on it with an LCD that you could modulate, and so you'd energize it, and you can get two-way communication by having external power.
Well, you can get tiny little size of the tip of your finger,
Yeah.
that are the ones they use in the calculator.
Yeah.
And they're 10, 15 cents each.
Yeah, yeah, you can buy, yeah, I bought, stacks of the bare ones, and you can
Yes.
use
And then you
glass
just
at
drop it
your
into some display and away you go.
Yeah, but it's the LCD display that I guess I just haven't spent enough time trying to source.
So it's a
Like a
transparent LCD.
transparent LCD.
Oh, okay, so it's just chip on glass.
Yeah, so I just want to power it, not power it.
I've
Maybe
definitely.
splurge on a 555 timer.
I definitely found some because I was thinking about like trying with like laser powered stuff to do like passive comms like that recently, and I was looking into the. You can buy those little LED shutters, so I think they because they sell them for shutters, so that you can buy LCD shutters.
Okay, just
Yeah.
go to the search for LCD.
Yeah, and I think they're like I saw. It was just like a passing fancy that I looked into for like a day or two, but I think there are a few dollars for the shutters.
It's like there's a street that I take to get to my house sometimes, and probably 10% of the time I miss it because I'm not paying attention. I'm like, damn it, I just want a reflective blue dot that is flashing at me whenever I drive by that.
Yeah.
Well, you can also have it so that it's protecting your car, you know, by Bluetooth or, USB or whatever. UWB transmissions, right? So as soon as you get close, your car's just going, hello, I'm here, I'm here. Oh, hello. And it's sitting on a street pole or something, you can have a tiny little cell and keep it charged up.
I mean, a lot of cars these days actually have Bluetooth LE in them all by themselves already, so you can just pick up the cars. Yeah, but I'm saying, but you could without even adding a tag to your car already has a Bluetooth LE tag in it, so you could just recognize your car by its MAC address.
Oh, yeah. So you're walking up to the car and you miss it, or is it drop while you drive?
Oh, driving.
Yeah, so that's what I'm saying.
Yeah.
Like, Bluetooth distance-wise isn't going enough. Yeah. So you want something to look more interactive.
Yeah, and I want to be able to give other people directions and be like, yeah, like drive until you see the flashing whatever on the side of the street. But I want to be able to throw it away basically and never have to service it. And there's scenarios where I might want to leave something and never see the person that goes to pick it up, but still leave some sort of. Yeah.
All right. Well, we can keep talking, but I'm going to put the microphone down.